It is too late. What you should had known before now. We're going to be talking about smart dust. Now, I don't know how many of you have heard about it. I don't know how many of you may know much about it, or maybe you know nothing about it. But when you take it into the context of what particularly we have been studying here of late, there is something that we need to take a look at. And if only for the reason to see if this is yet another piece of the puzzle that we need to be considering. So what is smart dust? Good question. A lot of misconceptions, a lot of different ideas out there discussing what smart dust is, but we're just going to look at it from simply a technology and manufacturing process. So smart dust devices are tiny wireless micro electrical mechanical sensors. They call them MIMS that can detect anything from light to vibrations. Nodes in smart dust are called motes. These motes contain sensors, computing circuits, bidirectional wireless communications technology, and a power supply integrated on a tiny dust size device. Okay, now this is a lot of what we would call smart dust on a drop of oil. So, and it's coated, as you can see. So, yeah, they're small. Now, been around for a long time. Technology came out about 1966. Back then, it was available, get this, in wireless radios, data processing, networking protocols. So imagine that this has been around now for, well, you could almost look at it, it's coming up on a quarter of a century. And in technology terms, that is a lifetime. So how does it work? All right, so smart dust is a network of motes, much like node in T technology. Identical or similar tiny computers consisting of 4 miniaturized components: ambient sensors, wireless transmitter, CPU, and power source. So the design is brilliant, very simple, very simple. Now, this is smart dust that has been made by Hitachi. Very, very small, as you can see. They were one of the world's first developers of the RFID. This is what it is: chip, nickname powder or dust. The surface area of the new chips is a quarter of the original, 0.3 to 0.3 millimeters. 60 UP thick chip developed by Hitachi in 2003. And this RFID chip is only 1/8 the width of the previous models. So you can see we're getting now into generations. Says Hitachi expects this tiny size will open the way to new applications for wireless RFID chips. The RFID powder can be incorporated into thin paper, such as currency, creating so-called bugged money. The RFID locator can identify special radio frequency identification tags from a distance of up to 183 meters, 600 feet, folks. And the RFID chips have GPS capabilities. Now, everything today is done by RFID. And when you add in GPS, well, folks out there in communications, military, police, law enforcement know how easy it is, how you can begin to triangulate anything. And it continues to say, by taking advantage of the merits of compactness, high authenticity, and wireless communications, and combining it with internet technology, the U chip may be utilized in a broad range of applications such as security, transportation, amusement, traceability, and logistics. Well, folks, I can certainly assure you that it has now gone light years ahead. So the fabrication of smart dust, here it starts out with silicon. You can see that it's etched, goes through the manufacturing process, and eventually it ends out as smart dust. Release of oxidizer, O2. Isn't that interesting? How oxygen is more, it's just a corrosive, you know? Anyway, so now think about this. It's been out there. We're going to talk about how it's dispersed. But literally, our brains very well are already infected with potentially millions of these motes. So let's look at two things here. Let's look at a normal brain and a virtual brain, okay? Virtual brain being what many people are now exchanging their normal brain activity for one that is more programmed on a virtual level called the internet. All right, the normal brain brings input through natural neurons. The virtual brain brings in inputs through silicon chip or artificial sensory cells. A normal brain has the interpretation by different states of the neurons in the brain. Interpretations is set of bits in a set of registers. Output on the normal brain is through natural cells. Virtual brain output is through silicon chips. Normal brain processing through arithmetic and logical calculations. The virtual brain's processings are through arithmetic and logical calculations and artificial intelligence. The normal brain memory storage through permanent states of neurons. The virtual brain memory storage through secondary memory. The virtual brain is in all points superior to what the normal brain is doing. Now, in calculations, etc., it's now being matched. But this is important. This is what the electronic devices, the Wi-Fi, all of this is connected to, is that more and more of us are exchanging our normal brain patterns and functions for a virtual brain that has been programmed. Think about this. We're all plugged in. And when you begin to talk about motes and what they can do, what they're designed to do, and what they're already doing, every one of us, this is our brains. So think about this. You have a neurostimulation device. This is activated, as you can see, from the peripheral nerves right here, right? Then you have neuromodulators boost sympathetic plasticity. Whoa. This is, I guess the best way to say it is that it's mimicking the brain in its matter. Then you have the neuronal connections are tuned to improve cognitive skills. Are you starting to see where this is going? And it's not a fact that it's going, it's already here. So check this out. So this is how it works. As you breathe this in, as you walk around and it gets attached into the epidermis, then what happens is that the process. You have an external transceiver. This is a long-range transmitter. You can see how it can rest right on the epidural. By the way, when you think about the epidural, that's your skin, is that it has chemical reactions, it has power that's fed to it. It's quite unique. I mean, you know, you've heard the term cold hands, right? Warm hands. So think about this. It attaches right here onto the skull. Now you're breathing this stuff in. It gets into the bloodstream, right? Then you have the subdural transceiver. This is an ultrasound transceiver to a neural dust. The transcranial transceiver for external communications. It's a polymer encapsulated. Now it resides right on the cerebral cortex. This neural dust is a polymer encapsulation recording sites, the CMS front end. Folks, it feeds information both ways. Smart Dust was a research proposal to DARPA. We're going to talk about DARPA as we end this. About 1997, that's when it was first prototypes. And you have to understand, back in 97, there was no thing called Wi-Fi. There were cell phones, but it was on an analog network backboning the AT&Ts and Bells. Imagine where it's gone. So the Smart Dust Mote is an electronic package composed of an integrated circuit, radio transmitter and receiver, a microcontroller, a random access memory, RAM, a flash memory, some standard sensors, analog to digital converter, a power source for the motes, an antenna used by both transmission and receiving signals. Ladies and gentlemen, this was literally almost a quarter of a century ago. Where do you think it is today? Now, this is how it works. These are actual synaptic pathways of your brain. These motes connect in, they're floating, they're freeform until they get connected to the nerve. This is what it actually looks like under a micron microscope. It's all around us. It's in you, it's in me. It's everywhere. When you dust, there are the most likelihood those are in what we dust. And if there's anything to the chemtrails theory, well, this is why the dispersion. And once inside, they are impossible to get out. Think about this. The technology is real. The science is real. The mechanical operation works. What is this saying that it would appear virtually every human being has taken the mark? The only thing you can say. When it's coated, disposed of a dispersal, of a disposal aerosol, Yeah, this gets pretty weird, folks. Now, begin to think about, learn to think small here. We've been talking at length about quantum realities, quantum computing. Think about every human being plugged into a neural network. So let's talk about the MEMS technology. As I said, it's an microelectrical mechanical system. It's an integration of mechanical elements, sensors, actuators, electronics on a common silicon substrate. Now, while the electronics are fabricated using integrated circuitry, the micro-mechanical components are fabricated using compatible micro-machining process. It's easy to disperse, very easy to disperse. And it's in every device that you and I use. As I said, once inside, almost impossible to get out. The three tech giants, and there are now many of them around the world, are heavily invested in this smart dust technology. Now, I was always an opponent of government health care, but no one read the nearly, well, that time it was 28 pages, 2,800 pages. I think by the time it was done, it was nearly 20,000 pages. But under the Obamacare, the Affordable Care Act, it was mandated by 2017 that system-wide implementation of implanting of chips begin to take place. In fact, the law actually reads by 2018, if you're going to get a subsidy, that the government has the right to tag you. I think they figured another way out, another way around it. So the future of smart dust, they've already thought about this, is likely to be the core industries of the future world. Tech giants, Cisco Systems, IBM, Google, Microsoft, you name them, started investing millions of dollars decades ago to employ smart dust and systems and networking technology. There may be an opportunity to integrate this technology into mobile solutions to transform business processes in the future. Folks, when this was written, we didn't really fully understand smartphones. They were still being developed. Now you know why they're called smartphones. So what are our conclusions? Smart dust motes incorporate sensing, computation, communications, and power in the, and this is the I think this is, help me out folks, I know this is what, is it the micromillimeter? It's a measurement of electricity here, that's what I'm saying, and small. Free space optical communications offers advantages in terms of size, power, networking, throughput. Optical, folks, on the technology, the software and hardware are open source. Many potential civilian and military applications promising technologies if costs go down, and they have. On the regulatory aspects, investigating their impact on existing services, low power devices, folks. So this is where we are now. I would say by now it's everywhere. Everywhere. And if you give any substance to the chemtrailing, it would appear that they have accomplished what they were looking to do. If this is what it was, is this part of it, you know, to saturate every human being with these nanoparticles, these smart dust. I mean, are we seeing the transformation of the human species in a manner that most of us could have never even imagined? When we speak of Wi-Fi and we speak of the fact that now Wi-Fi saturates everything, it forms a bubble around us. It interferes with our natural biorhythms. Can you imagine now that you have nanobots inside of you? Because you can't deny this. The technology is here. It's in every device that you carry on you. Folks, if you see these going up around you, understand this is not a communication device. This is a weapon. So I'm going to close out with DARPA. Since DARPA is the one who has funded this technology coming out of our public universities. So in essence, we the American people own this technology. DARPA is bringing a new reality. This reality is already here. Folks, the bots, the robots are here. This is how they're going to intend to do it. Look how you do this on the battlefield. You have your soldier here. Now he is wearing a neutralizing device. You have the air support here dispersing the particles, the dust. It saturates the enemy and everything around the environment. You have up here where you're now saturating this, and now we can detect other anomalies as the dust attaches. Think about it. So I want to close this out with how this is being done in many cases. There are individuals who are getting implants. You can call them pacemakers because they're actually miniature. Oh, man, you can just call them miniature comm centers. Now, they begin to put a wire, feed it through, connect it into the brain itself. Now, with the smart desk technology, with the motes forming a synthetic synaptic pathway, you've just built yourself your first transhuman being. And if you begin to understand where we're going and unlocking the gene code, you can actually begin to see how you could transfer a consciousness into a now rewired, remanufactured brain. Smarter, faster, more intelligent. Yeah. This is a future. It's a future that we the people have invested in. It is a future we the people may not want, but it appears it is the future we the people are going to get. And when you take the fact that the human race is a hybrid race to begin with, you begin to see it's all connected. You should think about this as to what it's doing to you. Because if it is true that we are all infected with these motes, how can we tell if anything anymore is real or merely an electrical impulse being sent to all of our brains.